for this. So kind of putting in perspective, the LiDAR equipment, say 5 years ago, this was the cost of, a medium-sized house. So it'd be $200,000 up to $300, plus $1,000 to get hardware that would then require quite substantial knowledge of like how to operate this system. It was very hands-on, took a technician with a lot of training, and kind of paralleling this was this photogrammetry world, where we had companies like DJI with these the Phantom drone that really just pushed the frontiers of getting orthophotos. And this is essentially a photo that has geolocation information to it, and it can also have some orientation, pitch yaw roll of that photo as well. But so this kind of innovation in hardware has led to an innovation in GIS, where now we have the readily available of this type of data set. So we've been on a mission basically to simplify and reduce the price and increase the access to LiDAR, as a new form of kind of a commodity data source. So at ROBOTIC, which is the company that myself and my brother, we started this company, and we've been pushing the frontiers as hard as we could. And this product here you see on the screen, this is called the R2A, and basically what this is, it's all the same hardware that you would find in a $200,000 system. And we were able to really make some deals with the devil to get the prices down, so that way we can get products out to people's hands. And then several other factors here was just how do you using LiDAR. It was so complicated. I don't know why, but to be able to just do an acquisition was required, laptops, specialized cables. You'd have specialized software on that laptop to communicate. It just wasn't a happy experience. So inevitably you would screw things up, and I did many times. That sucks, because then you have to go back out and do it again. So just how do you make it idiot proof? If I can do it, anyone can do it. So that's, we really have been working hard on that, and we think the future is LiDAR data. It's just another data source, and it just kind of maybe jumping into more generics here of like, what is LiDAR? This photogrammetry. I use photogrammetry all the time. I use LiDAR all the time. When would you use one over the other? So LiDAR has a couple unique aspects to it that in certain situations it benefits over photogrammetry. And this is going to be, it's this active laser source, and so that laser is coming out and mapping, traveling away from the device, bouncing off and reflecting back and measuring that distance. And so one of the cool things is that laser pulse can actually go in between leaves. It's not like weaving around, but it's basically just seeing through the little holes. So if you see light on the ground and you on a walk in the forest, it's the same exact concept. Some of those laser pulses will make it to the ground. So the ability to map the bare earth underneath heavily vegetated areas is just a huge benefit to LiDAR. And so if you have a big flat field and it's wide open, then fly your photogrammetry. But if you have a forested area or area that has some tree coverage and you still need to get that bare earth topography, that's when the LiDAR really is going to come in to shine. Then we have other situations. So in the world of like linear asset inspections, so like power lines, we want to be able to make up these fine details of these wires. And in photogrammetry, to be able to kind of basically the rule of thumb for me that I think in photogrammetry is anytime there is a 90-degree or a sharp change, like a wire would be like, if you're looking at a photo, that wire is really close to you, then everything else is really far from it. So there's a huge first derivative on that depth. It just changes rapidly. And so photogrammetry oftentimes will not resolve that really well. And so that's when the LiDAR is going to be able to, one laser pulse will hit that, the other laser pulse hits the ground behind it. And so you can start really getting, specificity on these 3D objects. So that would be so when you're trying to do these linear assets like power lines, LiDAR is a productivity tool. Photogrammetry can do it, definitely does work, but you're just going to be taking a lot more photos to resolve these kind of more, finite objects that you need to do specificity with. So that's kind of the world of when you'd use one or the other. And what we're trying to do is just make it. It shouldn't be a cost thing. You shouldn't be saying, well, LiDAR, we're going to use LiDAR because it's really expensive or whatever, or we're using photogrammetry. Just use the tool that's best for that job, and be done with it. So that's what we're really striving to do, is like change that topic in the boardroom, or change that topic whenever you're discussing how you're going to do a job. It shouldn't be like, this one's so expensive, that one's so cheap. It should just be, well, just what do we need? And we'll just use that because that's what we need. So yeah, this product here, this is the R2A, and basically it's an integrated camera. It's got a 24 megapixel Sony camera on here, so it captures these ortho photos, and then it gets the LiDAR data at the same time. It uses those ortho photos to colorize LiDAR data, so you get this colorized model, but it also is ortho photos that you can use in Pix4D, Drone to Map, Drone Deploy, and still do the ortho photos as well. But I think I can share a few projects. So the other side of it is, how do you handle LiDAR data? And there's a lot of tools in the marketplace. So the typical workflow of LiDAR data, it involves first capturing it and doing this pre-processing step. So pre-processing, what I consider pre-processing, is going from the raw data. So you have a base station, you have a rover, so a GNSS, kind of a differential GNSS system, and then you have IMU data, which tells you the orientation. You got this laser data, all this raw data. But really, all we want is this geo-rectified LiDAR point cloud. So there's this whole pre-processing step that takes you from that raw data, just measurements on the device, to getting that 3D model. So that pre-processing step, every vendor you'll ever talk to will have their own software that does this. So, and that's typical, that's normal, and I wouldn't expect anything otherwise in the foreseeable future. That just is what it is. But then once you get to having a 3D point cloud, what do you do with it? Because point clouds really aren't the end deliverable for anyone. No one's really asking for a point cloud, just like no one's asking for a photo. What they're asking for is an asset inventory, or they're asking for planimetrics or contours, or all of these final deliverables. So that's where kind of the Rock Cloud comes in. This is a platform to host LiDAR data, to visualize it, to share it, and to process it. So I can click on a project. This is a kind of a land surveyor demo, and you can see here the way that the LiDAR is flown in this kind of lawnmower pattern, back and forth. Then here in these green dots, these are all ground control points that an independent surveyor went out and captured. So a little bit about ground control in LiDAR. So how does ground control relate to LiDAR? This is probably a good question to answer. So in photogrammetry, it's a little bit different. So in photogrammetry, you're doing this aerial triangulation. So you're looking for two photos and they have matching features, and you want to match those features. And so basically by matching those features, you're discovering the pose of the camera. And so you want to find these poses of the camera so you can project these photos onto the ground. Now, each pose, each photo that you're taking has a little bit of error in it. So what can happen on the actual result is you get a warping. So the whole orthomosaic can have warped distortion in it all throughout it. And actually, they all do to some extent. And that's why you're going to have a well-placed ground control tying in these points to the real world. So at that point where you tie it in, it's going to be very accurate. And then in between that and to the next point, there can be some warping distortion until it gets tied into the next one. So this is just, a manifestation of how the algorithms will process a bunch of photos into a map. It's got to orient all the photos, but there can be little errors accumulating. LiDAR is a little bit different. So it's a direct projection onto the ground, and you are basically relying on just an RTK or a PBK solution of GPS. So you're looking at basically this imagery ambiguity fixing. I mean, this is complicated stuff, but in surveyors, when they're going out there with a base station and a rover, as they're walking around, they're getting accurate data of where their rover's at. Or maybe they have their rover tied into the local Department of Transportation. They have some sort of in-trip server. They're getting corrections fed to them over 4G. And so same way as that surveyor is going out and has accurate data on that rover, this is the exact same way LiDAR is working. So in this sense, as long as you have connection, as long as you're recording that data, it's going to be geo-referenced correctly. So you don't have to worry about tying it into a bunch of control points. Really, all you have to do is worry about having one control point to do some sort of global change to the whole data set. So that's going to be a big difference, is the number of control you need for photogrammetry, the number of control you need for LiDAR, substantially different. So in this project, they did photogrammetry. That's why there's a ton of control points here. But I piggybacked on them, and I threw it in this data set because I thought, hey, if they're doing that, I might as well just throw that in there as well. Doesn't hurt anything, but none of it was really used in the actual production of this data set. So you can see here's one of these aerial targets here, and the red dot is a point from a surveyor, and all of the dots, so this is the LiDAR data. This rock LiDAR system. You see it just kind of lies up right in the middle there. And some of the things that you want to do with LiDAR data would be to, like I said earlier, is get some vegetation here. You want to strip this off. And so here we can actually show the ground only. And I'm going to change this view to elevation instead of the RGB. It makes it a little easier to see. So like I was saying, so in general, one of the big things with LiDAR data is the ability to see underneath this vegetation. So here we have a big clump of trees here, and you can still get great data, and then you can actually generate a topography, a contour from this system. And then the other data deliverables is like a digital elevation or digital terrain modeling, break lines for hydrology. So all of those things are done as well, on these data sets. So I'd say, this is basically LiDAR in general, and kind of what we're doing is we're trying to change the relationship. We're not taking away processing from people. It's something that I feel like you don't really want to do anyways, because for me, I've been processing LiDAR data using Terrasoft. There's several desktop softwares available that will take the data. You can classify it, and essentially the classification process looks something like this. You get raw LiDAR data that you produce in this LES. Now you have 3D points all over the place. You can even see some here in the air. It's totally normal. A bird flies under the sensor, you get some points there. Lasers also interact very funnily with solar cells and mirrors. So whenever you have that, you can get some data that's way below the surface. So the processing of LiDAR data looks like, first you want to clean up these above really high points. You want to clean up these really low points. So you're stripping those away from the data set. And then you want to start classifying the ground. And then so once you get the ground kind of classified, you're going to have a lot of trees, buildings, cars, other objects that kind of get lumped into that ground class. So then you're going to go through and manually clean that up. So you're going to zoom around and go, this isn't ground, this is ground. And so there's a lot of manual intervention. And then going from that to the trees, the vegetation, then generating surface models. So going from, now you have points that are classified as ground. You want to make a 10 surface model of that, and then clean up this 10 model, and then generate a digital elevation model from that. So that's kind of like the pipeline one would go through with a desktop software. They'd be cleaning up these outliers. classifying ground, cleaning up the ground class, making a surface, cleaning up the surface, producing a final surface, and then making contours from this surface that's cleaned up. So our kind of business philosophy is just saying, we'll just do all those pieces. And then that gets you, now you have the data, you have the contours, the surface model, and then you can do the next step, which really is importing that into Esri or whatever GIS software you have and using the data from there onwards. So no need to really become a PhD at processing that raw LiDAR data. You can just get the deliverables that you need and put those into your GIS software of choice. So that's kind of the business model of ROC, and what we're trying to do with the hardware and what we're doing with the software is creating this, basically a workflow where it's just, you just go fly LiDAR, like just get it when you need it and then use it for the project that you need to use it for. But you don't need to stand up a whole department inside the company to do all of these fine details, which are kind of repetitive.
How long would a project like that take? So you're basically flying it, or the person's flying it and uploading it to your cloud version, and you're processing that with the software, or we are processing that, and it's all automated?
All automated, yep. So we developed a bunch of AI algorithms that do this really well, but we have a small QC QA staff. So this flight right here was about, so it's 91 acres. That took about, I think that was about 5 minutes to fly. And then that pre-processing step I mentioned, it's about 1-to-1. So it took about an hour to get the LAS data. And then from the time of uploading it to getting the contours, DEM, just under 24 hours. So you'll see like an instant classification on the cloud. So our AI runs through it, and you'll get that right away. And 9 times out of 10, that's perfectly well. But we QC QA and give the final like deliverable over in 24 hours. Then let me show this data set real quick. This is a power line. So some of the other work that we're getting into is more vegetation management for utilities. So here we have just a bunch of alerts here on a map. These correspond with kind of these alerts. But basically, what are these alerts? These are locations of vegetation encroachment.
I think we're not looking at your screen.
Oh, did it freeze? Cool. Try it again. How about that?
There you go.
Cool. So I can go back to the other. Basically, I had a map view with a bunch of pins on it, and then jumped into Google Street View, and I was just trying to show that. I'll go back to the map in a second, but LiDAR data is just pretty stuff. So this is an example of what we're trying to do for the utility industry. We're really trying to push on this vegetation encroachment, where you can use an inexpensive LiDAR, fly 10 to 20 miles of power lines in a day, and then upload this and get a full classified LiDAR data set with all of the transmission assets and then the vegetation. And then these are all 5 feet, 10 feet, 15-foot encroachment violations. But the cool thing, to me, I think the coolest thing is that all of this is communicated in Esri shapefiles. So going from you flew, now you have this violations, and then importing that right into a portal-to-portal communication, or just having that as a feature layer service that's available, and having that show in real time on your Esri geodatabase is something that having that tight integration it's been really something we're pushing hard on. So this is the future of vegetation management for utilities is what we're hoping.
Yeah,
Yep.
I can see airports also using this for encroachments for the trees into their air navigation easements.
Absolutely. We just finished a project up in Alaska doing this exact work for a couple airports up there. These are not Alaskan airports, but this is some Regal data and our data kind of in one area, false colored elevation. But yeah. So yeah, does anyone have any questions about LiDAR or what Rock is doing or what the future outlooks are like?
I think it's pretty cool stuff. I think the LiDAR sensors are getting less expensive, which is also nice.
Yeah, I'd say, right now there's a new system coming from DJI. Actually, I have it. I have the only DJI LiDAR in the world right now in my room. And we renamed it. Its new name is called the Fuzzitron 3000.
Yeah.
If you want some fuzzy LiDAR data, it'll get it for you.
It's pretty tough to get good product out of it, huh?
Yeah, well, they're going to be selling it for like $10,000 to $12,000. So I would say that it has an application in like county mapping. So places where you need 20-foot contours, like that will crush it all day long. Like if you're just trying to get a 20-foot contour, I think 1-foot contours is going to be pushing it. I think that's going to be the upper limit that I wouldn't feel comfortable using it on a job at the way it stands right now. And then I think it's going to be interesting to see how it does just for basic asset inventory. So just say maybe you want to capture all the manholes or just the GPS location of distribution assets, or you're looking at, you just need to get some sort of rough information in order to put it into your geodatabase. I can see that being somewhat useful in that area, but it might not be good. It's the Fuzzitron 3000. Again, it's called the Fuzzitron 3000 for a reason. So anything that you can imagine a solid, thick fuzz on it and you wouldn't be able to tell what it is, well, then you probably won't be able to tell what it is.
Are you saying the XY coordinates are good? It's just the horizontal is pretty bad?
The XY and so all of them are pretty bad on that one. So the our system is about 5 centimeter. So we can do, on a surface, we can do 1/10 of a foot. And then on that XY, we're down below like a couple tenths of a foot. But that DJI one, right now you're looking at feet of fuzz.
Mm-hmm.
The whole thing is just fuzzed.
I could see using it for updating our LiDAR in certain areas. We have 2-foot contours, or the ability for that. We have a class 2 LiDAR data set for the entire county. So there are changes throughout the county, but we had some major flooding in 16 and 18. So we've had washouts on new bridges and different culverts, and the streams have rerouted in certain areas. So we just recently got 2020 spring aerials. I was looking at that, and you can see some definite rerouting. How important is it to have LiDAR that reroute? I don't know yet, unless it's maybe a major reroute where it affects the watershed, maybe.
Absolutely. Well, if it's down to the price range of, photogrammetry, I feel like, it can just be an add-on to a project now that if it helps, then you can do it, and it doesn't cost too much, then it's easy. So, yep.
How about we have some foresters here? Do you have applications for forestry? I think there's some volume stuff also.
So yeah, we do some canopy height models. We're actually, if there is people online that, so other than DBH, we're very interested in carbon credits and what is exactly needed on this. So we understand doing individual tree segmentation, and then the kind of the crown volume, as well as just canopy height models for like a very broad area. But we're in an active like gathering of information about what would look like, what would the final deliverable be for a forester. This is something that we're actually trying to understand better. We've done a lot of projects for foresters, but we never really understood what's the end product here with LiDAR data. I understand how to go out and throw a diameter tape around a tree, but yeah.
Mm-hmm. Yeah, I think with their, I don't know if they want to speak up during the meeting here, how they do collect their volumes, and maybe a little bit about the carbon credits. I know our county's been doing some stuff with carbon credits. I don't understand it that well, but
the black magic of the forestry world. Yeah. This is just a little example project. Was down in Georgia a couple months ago. Bunch of trees. Move them.
And how many points per meter are you collecting on these trees?
So the system it's doing 240,000 points every second pointed down. And so it's different than a full 360, where typically you'll see that number, but you got to divide that by 5, whatever number you're seeing, because that's the field of view you're going to see on the ground. So we're getting about 300 points per meter average. Just a little bit overkill, but
yeah.
You can't fly fast and high enough with the regulations to decrease the point density enough.
Okay.
So yeah, we have one customer that flies at 400 feet. So the regulation for the UAS for drones is 400 feet. He's doing 20% overlap, and they're just going as fast as the drone will go. And they're doing 500 to 1,000 acres a day.
Mm-hmm.
And they're still getting their surface models are getting 0.2 of a foot on that. So they are.
And then the storage space for that and all that becomes an issue, or is that all in the cloud?
It's all in the cloud. It's not that big of a deal. You're talking about. You're definitely talking about 50s of hundreds of gigs. But then, don't tell everyone. Use the LAZ format instead of LAS and zip it up. Compresses it by a factor of 10. So definitely LAZ. If people want to get into a conversation about file formats in LAS, I'm all game. LAS is the worst file format in the world. We all need to axe this thing. Create a new one as a community. It's bulky, it's big, it doesn't allow you to do updates really easily. It's a bad file format. Almost like having a CSV of every point. Almost that bad. So, yeah.
All right.
Yeah.
Any questions? You write them in the chat if you want. Or speak up now. I don't see anything coming in. I'm interested in it. It's pretty cool stuff. I always liked the LiDAR. One of the biggest drawbacks for me was once you collect it, the processing.
Yep.
That's always the question.
Well, that's I own a couple of these Regal systems. These like $200,000 systems. Yeah. And we just flew it again the other day, and just processing the data, it's a dread. I don't want to do it. It takes a long time. But if you guys want to, if anyone wants to see that system or any other things, I do have a YouTube channel called Indiana Drones. And so Indiana Drones on YouTube, I go around and talk about LiDAR. So I have a lot of different examples. Pretty high energy videos. They're fun. I hope. I like making them, and I'm gonna make a bunch more. We're doing some stuff. I'm hopefully gonna be flying on a helicopter to land on an oil rig and do an as-built for a video coming up. That's a big one that I'm hoping for.